No, but I broke my calculator. And
Yeah, he broke it in Latin. He split it in half.
It's on you, not me.
So
No,
All right.
yeah.
I will only say this a couple times. Listen up, please. I want to say this a couple times. I'm going to say it every class period, but woe unto you that if you do not bring a calculator come test day, you're doing it all by hand. I will show you no mercy. So your instructions are to bring a calculator to class, use it for homework. I can't believe I'm actually saying make sure you have to bring a calculator because that seems like something you'd want to do, right? Not something I must make you do. Any questions on the homework?
No.
All right. I will collect it here in the class. No worksheet tonight. We might even, depending upon how this is going, how I feel, we might even have a review day before the quiz, but probably not. I purposely, every single day it looks like we got an A and a B, and I purposely, instead of force you to try to I don't know, consume a large amount of information, I break it up into nice little bite-sized pieces of information. All right, homework for tonight, copy down.
Can I borrow calculator?
No. Right, because everything is making that noise, please stop. Whose is that? All right, go put your lock. Homework, you're supposed to be writing down your homework. Yeah, you're gonna have it here in a second.
You don't need a calculator.
Homework.
You didn't do it? No, it's not.
Go ahead. What? I'm sorry. I got it.
I got a question.
Say what more time? She's collecting it.
I know that I have this.
Put that in there too. Hannah, what's up? Hurry up. Okay, we are up to, let's see, we had rectangle, area and perimeter, that's 2. We had square, area, rectangle, we're up to 4 formulas. We'll get another bunch today. Okay. We good, everybody?
Yo, there's the homework. It's hot in here.
It could be because you have a jacket on.
Because I know how tight.
You have a jacket.
I might be wearing a tie every day.
You look good. Sharp dressed man.
Yeah, he's wearing pants this time.
That's amazing.
Yeah,
All right.
make it for sure.
Up here, every day in this chapter, we're going to deal with a shape and a bunch of formulas. Your job is to understand the formula, understand what makes up the formula, understand how you go from shape and the numbers on the shape into the formula, and to do a couple of the calculations, right? Of everything that we do in this entire book, this is a really straightforward chapter. Every single day, it's the same thing. Shape, formulas, do the calculation. And yes, you have a calculator in front of you. Okay. As we go further and deeper into the chapter, like I said, it's going to be over 20 formulas, right? If you don't already have started your resource card, right, come that last day before the test, you're going to be writing 20 formulas on a sheet of paper, and you're going to forget, oh, I forgot one. I don't know what a triangular pyramid, what the formula is. However, if you already are writing those down on a resource card, then you're good to go. Here we go. Yesterday we did. And today we're going to do triangles. All right, and composite shapes. And we'll do the same thing today. All right. Yesterday we defined polygon, poly meaning many, gon meaning angles, as a shape made up of segments that we join at their endpoints. So Here's 3 segments. If I join them, not at their endpoints, but just randomly, we do get a shape, but we get an unrecognizable shape. However, if we do join these segments at their endpoints, we get a recognizable shape. That's what a polygon is. It's not because it's recognizable, it's because it's a polygon, and we've named our polygons. That's why it's recognizable. All right. The other thing we did yesterday was perimeter. Perimeter is just a big fancy word for the distance around an object. Okay, the distance around an object. And if it's a polygon, well, what we do is we add up all the sides. Okay, if it's a composite shape, right, we don't add up all the sides. We add up only the external sides of a composite shape. The last thing we did was area. And remember, I made a big deal about drawing little tiny squares and filling up a weird looking shape with squares and then say, count the squares. And some of you said, yeah, but this one isn't a square. It only filled up a little bit of the blue. Yeah, literally. Well, then you got to figure out the percentage of it filled up. And then add that to this one and then to that one. So it can become cumbersome when the shape is not a polygon. We would call that an irregular shape, but we can still calculate the area of it. Luckily for you, we're going to be doing formulas. Yesterday we did, technically all we did was a rectangle. All squares are rectangles. Not all rectangles are squares. So we did a rectangle and a square. We got perimeter and area formula for both, so we're up to 4 formulas. Okay? For a rectangle, remember the area was length times width, right? 3 times 7. And for perimeter, it was add up all the sides, 2L plus 2W. For a square, area was S squared and perimeter was 4 times S. And I said eventually we're going to stop with the perimeter formulas. Today's when we stop. And we'll just simply say add up all the sides. Everybody ready to move on? Yeah. Okay, new stuff. Triangle, write this down, please, box 1A. Well, triangle is a polygon. It's made up of segments joined at their endpoints. And there's 3 of those sides. Triangles have 3 sides. Duh. Tri, 3 angles. It's got 3 angles. Ironically, we define it as sides, but the word means 3 angles. Okay. A polygon with 3 sides. All right. Now, if you listen carefully, you will save yourself years of anguish. The next thing I'm going to say. Okay. The names to the parts of a triangle, right? Not the types of triangle. We already talked about that in the previous chapter. We go by angles. We have acute, obtuse, and right, equilateral. And we go by sides. We have scalene, isosceles, and equilateral. I meant equiangular for the angle. All right, here we go. Oh, I dread this. All right, you see what word I just put there?
Yes.
Guess where I put it?
Triangle.
Okay, Jaden remembers from last year when I gave this same class. Yes, 99.9% of the times, the base of the triangle is the bottom. But the actual definition of base for a triangle is any side. Write this down. Box 1, what are we on? A still? All right. Does that say A or B? All right, so a base of a triangle is not the bottom. It's a side. I just simply, and so do most mathematicians, so do you, we always choose the bottom. I shouldn't say that. We almost always choose the bottom. It's just convenient. It makes sense with the word base. But I can choose any side to be the base. Jenna, repeat my last sentence. Okay, now listen. The base can be any side. It doesn't have to be the bottom. Repeat the sentence. Why would I make someone repeat that sentence? It has nothing to do with Jenna. Why would I make somebody repeat that?
To make sure it's good in their head.
Right. Every year, I will have someone do the calculation for area of a triangle, and they will choose not the base. Guess what side they will always choose? The top. They will always choose the bottom. The bottom doesn't have to be the base. Don't assume that the bottom is the base. I'll show you what the base is eventually when we get to the calculation. What? You're fine. All right. All right. If we measure the distance perpendicularly, that means at a right angle, from the base to the opposite vertex. Vertex, right? Angle. You see what I did? If I measure the distance from the base to the opposite vertex, we give this white dotted line a name. Anybody remember from last year? We call it either the altitude or the height. Hey, write that down, please.
Yes, sir.
The perpendicular distance, it must be perpendicular. That means there's got to be a little tiny square there. The perpendicular distance between the base and the opposite vertex, that's the corner. Right here, the angle. We call that the base. I want to see writing on your paper.
Call it the height,
We call it the height.
not the base.
What did I say, base?
Yeah.
Okay, sorry. We also call it, put it somewhere in your notes, altitude. Our book kind of occasionally says the word altitude. That makes sense, right? If it's the base is the bottom, you know, how high is it, right? Altitude. We get to high school geometry, we don't use the word height anymore, we only use the word altitude. But for 7th and 8th grade, height's good enough. All right, the perpendicular distance between any base. What's the definition of base?
A side of the
Any side. Therefore, a triangle is going to have how many heights? 3. There's 3 sides, therefore there's 3 bases. The height measures the distance between the base and the opposite vertex. The bases could all be, if it's a scaling triangle, could all be different measures. The heights could have 3 different measurements. The only time the base and the height have the same measurements if it's equilateral or equiangular. Equilaterals are equiangulars. Okay, are we good with this idea of base and height?
Yes.
All right, we'll see. Box 1B, do you see it? 1B. We're going to draw these 3. You are going to draw these 3. Here's your first one. Where's the base?
On the bottom.
Draw that. Label it. Make sure you put the little 90-degree angle. That means it's perpendicular. This is what it's going to look like for the base and the height if you choose the bottom to be your base. Yes?
Yes, sir.
Guess what the next triangle I'm going to draw?
The base on the top.
Okay. Your second triangle, same triangle, choose either the left segment or the right segment to be your base. Draw the height. I should see pencils moving, David. Second triangle, I'm not going to draw it yet for you. Draw the same triangle, whatever you drew. This time either make the left side or the right side your base and then draw the altitude or the height. What does it look like? Does it look the same or different than this one? It looks different, right? Here's mine. Notice, not the same distance. This height's longer than that height. And you have an equilateral triangle.
Oh, I remember that from last year.
If you do, then you have an equilateral triangle.
My triangles are 2 different sides.
If your isosceles triangle was on the side, then it would work as well too. All right, there is a third construction here. No, I'm not going to draw the one on the left because it would look exactly like the one on the right, just reversed. There is one triangle where the height will not be in the, I don't want to say the middle, but somewhere in the middle. Guess what triangle that's going to be? There is one triangle that already has a square on it, and that is a right triangle. So check it out. Where's the height on a right triangle? It's one of the sides. Why? Because height is the perpendicular distance between the base and the opposite vertex. So for a right triangle, you won't have this little dotted white line. Does everybody see that? All right. Eventually, we're going to get to the area formula. The area formula has something to deal with the height. Guess where you're always going to look to find the height?
The right.
You're going to find the right angle. All of them will have the right angle. You're going to look for the little square first. Notice the little square touches both what? What does the little square touch? And the height on all of these. Base, height, base, height. The little square touches the base and the height. So when we do the calculation for area, I'm going to say find the little square. touches the base and the height. Okay?
Yeah.
Everybody? Okay, big but here is this. If I choose this is a scaling obtuse triangle. Do you see it? Do you see it?
Yes.
Okay. If I make the bottom the base, what's the problem? If I make the bottom the base, what's the problem?
It's not.
What's the definition of height? What's the definition of height?
Straight line perpendicular of the vertex of the base.
You were all messed up.
Whatever. I know what the.
It's the perpendicular distance between the base and the opposite vertex. Guess what the problem with this triangle is? If I make the bottom the base and I try to draw a perpendicular line, do I ever touch the opposite vertex? Never. This is the only triangle that always causes problems. This stupid scaling triangle. It's got to be obtuse scaling. It can be acute scaling, we don't run into this problem. But if it's obtuse scaling, if you try to draw your height, you never touch that side. You ready?
Yeah.
Who has not ever seen this before? Here is what they do. They will take this triangle right here and this height, and they will move it. They will move it to right there. I'm still measuring the distance between the base to the vertex, but I'm measuring it way over here. And the issue is, now it looks like a big triangle. You see the two dotted lines? Not part of the triangle. The triangle is yellow. The two dotted lines are an extension of the base and a movement of the height. The height is always a dotted line or dash. This is the one that I will have people give me from. Why? Because they're going to put a number right here, 6, which is the distance between here and here. Does that 6 have anything to do with this triangle? Nothing. If the base is 6, well, then the base is 6. Just because that number is 6 or 8 has nothing to do with the triangle. Jaden, what is your burning question?
You can always just put it on one of the sides that actually.
Right, but guess what? They're going to give you the picture. Jaden's saying, well, if we don't choose this as the base, we choose this as the base, then the height goes right here and we don't have a problem. Okay? Okay. Box 2. I want you to list the distance of the base and the distance of the height for all 3 triangles. 30 seconds. Go. Grab your pencils. The distance, the length of the base, and the length of the height for all 3 triangles. It should take you less than 30 seconds.
Yo, this is easy.
I have a question. What was 1 feet?
So the person who said it's easy, which I will not mention their name, Landon, got it wrong. Landon, what am I going to do with you?
You're supposed to add.
All right. Who remembers the previous statement I said about finding the base and the height? What did I say to look for? Angie? I said to find first the little tiny square. The little tiny square will touch the base and will touch the height. So Angie, on this first one, what's the base? What's the height? Works great, right? Where's the square? Okay, so is the base 8 centimeters? Well, 8's on the bottom.
Oh my God.
But the square is right here, so they're choosing the left side. So 15 is the base. This was not Landon's mistake. Landon's mistake is over here.
No.
Guess what he put the base as?
Okay.
He put 10. Why is that wrong?
Because
Because the dashed line is not part of the base. So the only time that my little find the little square will always tell you where the base of the height is this stupid obtuse scaling triangle. It always causes problems. If I could get rid of one thing in my life, it would be obtuse scaling triangles. Yes. Oh, by the way, Abby, what is the base and the height for this one? Well, I couldn't fool Abby. Now your question.
you said that you don't really use the 6.
I will not use this 6 to calculate anything to do with this triangle.
So then why is it?
To cause confusion.
Would you ever-
We will when we eventually get to more high school level math, right? And we're not going to see it, this year at all. But they're going to put that number there just to mess with you. Okay, we okay? Moving on. Perimeter of a triangle, what's the formula?
Base times height times height.
Perimeter of a triangle, what's the formula? Formula number 5, yes. Nope. Oh, Jaden? Add what all together? Add up all the sides. So here's my triangle. Now, I know if you had me last year, you've seen this notation before. Hey, is that square?
No.
Why not?
Side one.
It's underneath. For those who have never seen this before, when there's words or numbers or even variables, underneath a variable, we call this sub, like submarine, underneath, sub notation. You see any numbers or letters or variables or sentences underneath a variable, it's just a name, right? There are 3 sides, so we got to give the sides names. Side 1, side 2, side 3. I could have said side A, B, C as well. Okay, so underneath they're just think, hey, you think you need to write this down? This would be formula number 5. Yes or no?
Yeah.
If those of you that need it, write it down. The rest of us are going to be like Jane, which says, you just add up all 3 sides. And I'm going to stop with perimeter formulas now, after triangles, because it seems ridiculous. We're just going to add up all the sides. So here's your 5th formula. P for perimeter of a triangle, side 1 plus side 2 plus side 3.
Easy.
By the way, what's the perimeter?
It is 9 centimeters. 9 centimeters.
9 centimeters. Okay, remember, perimeter will always be base units, areas will always be units squared, because we're counting squares. We good? Perimeter of a triangle, nothing hard about that. Now, look up here. We learned from the previous chapter that you have these things called tick marks, yes? So, what's the perimeter?
16.
No.
Oh, wait, no.
24.
It is
22. 22. It's 22.
It sounds like we're in a football game here, right?
22.
All right. What's the perimeter here?
13.
Okay, what's the perimeter?
22.
22, whatever the
16.
units are. Okay, so you might see those tick marks come around again. Or it might say you have an isosceles triangle that has a base of 4 and one of the legs is 2. Well, that's the picture I just drew, right? All right.
Can I tell you?
Area of a triangle. Everybody stop what you're doing. Here we go. Hey, that's not a triangle. That's a,
Rectangle.
what's the formula for area of a rectangle?
Base times length.
Length times width. So if I take the length and the width, stay with me, that would be the area of a rectangle. Yes?
Yeah.
All right, hold on. I'm going to take my rectangle, and instead of calling it length, which is what most of you wanted me to call as the base, let's just call the length the base. Nothing wrong with that. Any side could be the base.
Yes.
Okay? What do we define as height?
Width. Or length.
What did we define as height? It's in your notes, unless your name is Landon.
The height is
The tick
is
marks.
like
No.
No base.
The opposite.
Someone who wrote down my definition, read it.
Perpendicular distance between any base and its opposite vertex.
Any perpendicular distance, it's hard to see, but there's a little square right here between the base, Hannah. Tapper. Hannah. Any perpendicular distance between the base and the opposite vertex. Hey, guess what we're going to call this distance now? We're going to call that the height, because it's the perpendicular distance between the base and the height. But it's a rectangle. I can draw the height here, or I could draw the height, and I'm going to choose to draw it there. Therefore, this is the height. Therefore, the new formula for a rectangle is base times height. You don't need to write that down. Okay? You want to use length times width, fine. You want to use base times height, you can. All right, now here comes the magic. That's not a triangle. But I can make it into a triangle by cutting it in half. So there's my rectangle. We said the formula for area was base times height. If I draw it's called a diagonal. How much area is right here?
A triangle.
How much area is right here? How much area is right here? Well, if I erase one of those triangles, it's not base times height because that would be the full rectangle. It would be 1/2 of the base times the height.
Right.
That's the form. Hold on 1 second. That's where the formula comes from. I just proved it to you. So yes, write this down, box 3. Now, I have 2 formulas here. Guess why?
Because either
This is what's in your book. What's the second one?
what you want to.
Why?
Make it easier.
Because it's easier. Why?
Because you
How do you type a half into your calculator?
You don't.
0.5. How many keystrokes is that?
3.
How many keystrokes is that?
Uh,
It says 2. It's 1 keystroke. If you type this in your calculator, base times height divided by 2, it's 1 keystroke to type in 2. How many keystrokes to type in a half? It's 3. You're either typing in 1 divided by 2 or 0.5. This is why the second one is calculator friendly. The first one is not calculator unfriendly. It just takes longer to do. Who's lost on this?
no.
This is the only thing that will ever appear in your book. 1/2 base times height. This is the only thing that any math student worth their own salt will use because it's easy. Base times height divided by 2. Me as a math teacher, I gotta show you the first one every single time. Because it's what's in the book. The book is, it's not a lie, it's just not as convenient as base times height divided by 2. So I will today only show you the first one. Yes, I encourage you to use the second one in your calculator. Who's lost? Let's do some. Here are the steps. Step number 1, Hannah, you will always take your eyeballs and look where when you have a triangle? At the, not the base, but at the square. You see the square? The square, unless it's that stupid scaling obtuse triangle, will always touch the base and the height. If you follow my advice, except for that one triangle, you can't get this wrong. Hannah, what's 2 times 3? What's 3 times 2? Even if you mess up the base and the height, you can still get this right because they're multiplied together. But you're not going to get it wrong because the square touches both of them. They are going to give you a triangle that has everything listed, left side, right side, bottom. If your eyeball goes to the square, you can't screw this up. Jenna, what's the base and the height of this triangle? Jenna, what's the base and the height of this triangle? Where should your eyeball go to find the base and the height? The square. The square touches the base and it touches the height. The height will always be the dotted line. The base won't be a dotted line. Okay? 8 and 7 are the base. 8's the base. 7 is the height. We take those 2 numbers. We multiply them together. We divide them by 2. Take both of those numbers, multiply them together. 8 times 7 is 56. 56 divided by 2 is 28. Or do the math in any way you want to. Look what I did. Right? I did a half of 8. Half of 8 is 4. Why can I do that? Because it's multiplication. You can multiply in any order you want. This is a half times 8 times 7. So if you didn't have a calculator, half of 8 is 4. 4 times 7, 28. I went left to right. With a calculator, it doesn't matter. Because if you do base times height, you'll do 8 times 7 divided by 2.
And don't forget that your calculator doesn't love you.
The calculator does not love you. Do the calculation twice.
Oh,
One last thing. We are not measuring perimeter now. We are measuring area. If we're measuring perimeter, it would be inches. If we're measuring area, inches squared. Once again, your eyeball goes to the square. The square touches the base and it touches the height. Unless it's that one scaling obtuse triangle. Okay? 10 is your base, 8 is your height. Many different ways of doing it. 10 times 8 is 80. Half of 80 is 40. Half of 10 is 5. 5 times 8 is 40. Hey, what's half of 8?
4.
Times 10.
40.
Doesn't matter. You still get to this number 40 each and every time units are squared. Who is lost?
I have a
Yes.
question.
Sorry, my hand.
Yes.
So why do you only do one of them?
Do one of what?
Like you only did the 8 when they're both.
Ah. Okay. So he's saying this. Why didn't I take half of everything? Right? Because that's not the way multiplication works. You can only multiply two numbers together at once, right? So when you multiply, you can't take half of both. If I go left to right, it says half of 10. Whatever that answer is, multiply by 8. Now remember, multiplication is commutative. So why did I only take half of 8? Because I can if I want to. I can take half of 8 and then multiply by 10. I can take half of 10, multiply by 8. I can do 10 times 8 and then take half of that.
I have a question.
What?
Yeah.
So let's say you have to add on to the.
We're not doing anything yet. We're just doing this one formula. We'll talk about addition here in a second. Okay, guess what the person who's not paying attention is going to do wrong here.
Add both sides.
They're going to say, what is the base?
10.
They're going to say 10 is the base. Once again, unless it's that one silly obtuse scaling triangle, the square will always touch the base and the height is always the dashed line. Okay, people won't mess up the height, they will mess up the base.
I would never do
This, yes, I see it every year, right? This is 9 times 8 divided by 2,
72.
36.
No, I'm
36.
9 times.
All right. If I were doing this by hand, I wouldn't take half of 9. I would take half of 8, which is 4. 4 times 9 is 36.
So then what happens if you think
Yeah, then you guys got to deal with it. Me personally, I'm always going to divide by 2 as the last step. That way I don't have to do two things with decimals. All right. Oh, and by the way, it's calculator, so none of this should give you any pause. Hey, there's no dotted line here
7.
because it's a right triangle. And remember, even on a right triangle, the little square touches the base and the height. Okay? Base doesn't have to be the bottom. It could have been the side. You could have said the base is 7 and the height is 10 if you wanted to. 10 times 7 is 70. Half of 70 is 35. 35 square inches.
Wow.
Who is lost? Easy class. Oh, by the way, this is not 8th grade. This is still 6th, 7th grade right here. All right. We'll get to 8th grade when we start getting to trapezoids and other shapes. All right. If there's only one triangle that will cause you problem, it's the
Last one.
It's the isosceles scale. I'm sorry, the scalene obtuse triangle. That's not a 6 and an 8.
All right, so
What's the base? It's a 4 and an 8.
So then would you do 8 so 4 times 4 then?
Where are you getting a 4? Oh, yes, what you said, but they weren't tracking what you meant. Yes. He already took half of 8, so half of 8 is 4. 4 times 4.
So y'all tell me that I have to subtract.
There's
4
no
from
there's no subtraction here.
How did you get 8?
These are not the drawings you're looking for.
Okay.
Base times height divided by 2. What's the base?
4.
What's the height? So 4 times 8?
But how did you get 8?
What?
How did you get 8?
It says 8 right there.
Yeah, but how did you get
What is half of 8?
Stop. No. You're talking something else than what he's talking about. What do you mean, how did I get 8? It says 8.
No, like, okay, so when you have to split it up, how do you get those?
What do you mean
numbers?
split it up?
Like, okay, so you got, let's say it's just a regular triangle,
Well, these are all the regular triangles.
but then you had to add on to that.
There's
triangle.
no addition. It's base times height divided by 2.
No.
No, he's saying add a triangle to a triangle.
Yes.
You're asking me.
That's because it's this one weird triangle.
Yeah, but how do you get the numbers that were added on from it?
That's
He's asking, how did I get,
Well-
how did you get 8?
I would have to show you some trig to get that part. You need, at this point, you need to just focus on the fact this is base times height divided by 2. How did I get the 6 and the 10? I calculated them.
No, the 6 and the 8.
That's the distance between here and the top.
Wait, so you do 12 minus 4. and
Oh my God, you need to stop and just listen to what I'm saying.
Okay.
Right. The little square touches the base and it touches the height for all triangles except this one. The definition of base is any side. The definition of height is the perpendicular distance between the base and the opposite vertex. There's no vertex here, which is why this whole thing has been erased and moved way over here and then measured. Somebody measured it, not me.
Wait, so then wouldn't that be 4 meters instead of 6? Because you're moving.
Okay, see me for tutoring. All right, everybody else, we good? All right. First one, what'd you guys get?
3 inches.
I got 3 inches.
Second one, what'd you guys get?
75
Centimeters.
centimeters.
And the last one, questions. Are we good? We've accepted a couple people. Hey, no joke. You can get lost. You can get lost. If you get lost and you are the 1 or the 2 people and the rest of us are ready to move on, this is a tutoring thing. That means next week I expect you to see you. Hey, explain to me that stupid scaling obtuse triangle. I still don't get it. That's perfectly fine. But the rest of the class, we're moving on. Yeah.
The thing like you are, if you do like divide one of the numbers, is that the divide by 2?
Right, and just be careful with that. Make sure you're dividing right, but you can definitely do that. All right. Last thing we didn't do a full composite, so we didn't do the calculation. We just talked about it last class. Now we're going to do one. So composite shape looks like a T, right? Here's how it's done. Composite shape looks like a house, right? Hey, what can you make this house with? Triangle and a rectangle. Okay. So if I have a triangle and a rectangle looking something like this, and it says calculate the area and the perimeter, the one that will cause you problem is the perimeter. Why?
I don't know.
Because this distance, if it's a triangle and a rectangle, let me draw it like that. This distance right here is that part of the perimeter.
35.
Perimeter is the distance around the shape.
No.
This part right here, he learns I point to the top of the rectangle. It's this part of the perimeter. So you have 10 total inches that are not part of the perimeter. All we're doing is calculating the distance around this shape. That's perimeter. For area though, oh heck yeah, I need those distances. Length times width or base times height.
60.
For my triangle, I need base times height. So I will need for this triangle right here, the fact that it is 5 inches and the height is 2 inches. 5 times 2 divided by 2, 5 inches squared. I will take those two calculations, the area of this triangle with the area of this. What's the area of the rectangle?
60.
60. I will take those two calculations. The area of the triangle we said was 5 inches squared. The area of the rectangle we said was 60 inches squared. And what will you do with these two values? You add them. Who's lost? This means the area of the composite shape. All right, have a good weekend.
Don't forget the worksheet.
There's no worksheet. Who said they needed the worksheet? That was Angie. I'll get it to you 6th period.
No, there's no 6th period. Oh, wait, never mind.
If somebody can help Landon in your off time and explain it better than I did, and then you won't have to come to tutoring. If not, I expect to see you for tutoring, Landon. Nate, you good on this stuff?
Mr. C.
Oh, I'm sorry, Donovan. What's up?
For us, the e-learners, there's a worksheet, right?
No, it's this right here, 1 through 10 all. Yesterday was a worksheet. Today is this.
Oh, okay.
Since you come to class, then you're online. Some of the e-learners are a day behind, so they had a worksheet today because it was yesterday's class.
Okay.
Make sense?
Yeah.
Cool. Have a good weekend, Donovan.
Okay, you guys too.
See you later.